Hey everyone, welcome back to the PlaneMaker tutorial series. In this video I'm going to show you how and why you might want to implement a artificial stability system in your aircraft's flight control system. So without further ado, let's just get started. So I have the fighter I've been working on open in PlaneMaker. I've made a few changes, that's why it might look a bit different. But right now, as it stands, this fighter is not the easiest to fly because I've given it thrust vectoring, I've given it very large control surfaces, and it can change its direction very, very easily. And while this is probably okay to fly as it is, it could be better. And that's really the main purpose of giving yourself artificial stability in PlaneMaker, is to make your aircraft easier to fly. X-Plane doesn't really handle negative stability very well, so I would strongly recommend not implementing it, because the artificial stability system just can't deal with it. But if your aircraft is just a little wobbly in some axis, you're encountering adverse yaw, you're maybe rolling too quickly, or you just want to make it feel a bit smoother to fly, then you are definitely going to want to consider implementing an artificial stability system. And fortunately, it's pretty easy to do. It's just a bit confusing at first. So to model your artificial stability system, you want to go to Expert, and hey, surprise, surprise, artificial stability. And so here in the artificial stability page, there are two kinds of artificial stability you can have. You can have a low-speed system and a high-speed system. And each of these systems will try to get the aircraft to perform at a degree that you specify here, based on some amount of stick deflection. So you aren't directly moving the flight control surfaces anymore. You are telling the computers what you want the aircraft to do, and X-Plane will try its best to get the aircraft to do that for you. So you can use both of these systems in a single aircraft. In fact, it might be preferred to do that just because at slower speeds this system might do better than this one. It really depends. It's up to you and your aircraft. But for me, I'm going to start with a high-speed system, because I've been noticing that in my aircraft, without artificial stability when I've flown it, it has a tendency to exceed angle of attack. It has a tendency to overshoot the angle of attack that I want it to be at very, very quickly because of its thrust vectoring and large control surfaces and all that. So what I'm going to do is I'm going to make a high-speed artificial stability system that will command an angle of attack. And now this section here requires us to go back a little bit into control geometry. And in control geometry, if you just create a slat as default, it will increase your stall angle of your wing by 8 degrees. That's important, remember that number. Now, airfoils in X-Plane. X-Plane does not actively calculate the aerodynamic performance of an airfoil above angles of attack of 20 degrees. It just kind of interpolates based on what it thinks they should do. And while that's fine for most applications, what it means is if you have a fighter like this one that has leading edge root extensions, which are supposed to create vortices under the leading edge of your wing to give you more lift at high angles of attack, it just won't happen in X-Plane because it doesn't model that type of airfoil. So you have your 20 degrees maximum angle of attack of the wing, and then you have 8 more degrees that slats will give you. That means that unless you have thrust vectoring, which I do, but we're just going to ignore that for now, the most angle of attack you will be able to sustain in flight in X-Plane is 28 degrees. For that reason, I am going to say that the maximum angle of attack that this aircraft will be able to command with full stick deflection, that's specified here, just leave these all at 1 for now, that'll be 28 degrees. And so now you can see there's a few other numbers here. Looks like I still have some from when I was experimenting. But basically there are two values you need to set. You need to set the fraction deflection per degree difference, and then the fraction deflection per degree per second. Basically, what this number does is this determines how much X-plane will correct the position of your flight controls to account for the difference in the aircraft's actual angle of attack and the angle of attack you have commanded based on your stick position. So I only really use two different values for these. If I need it to correct a lot, I say 0.1. If I just need it to be a bit more stable, I just want it to feel a bit smoother, I say 0.05. For this aircraft, I'm going to say 0.1. Same thing here. If you need it to move a lot, if you need it to correct a lot, if you need it to correct a little, it just depends on what you want it to do. 0.1 or 0.05, sorry, is what I found to work best. And the process is generally the same for the other axes of flight. You'll notice you also can do the same thing with angle of attack that you can for G-load. If your fighter is really good at sustaining high Gs, like if you have an F-16 or something like an F-16, then you'd want to do something like that. Again, same process, either 0.1, 0.5, depending on what you want your system to do. And so, in heading, target degrees of side slip, I want this to stay, actually no, let's not use this one. I'll explain why in a bit, but I'm just going to remove all of that there. And you'll notice that roll rate here is the same as roll rate up here. So you can do either one. This will activate above a speed, this will activate below a speed. So what I'm going to say is when I am going fast, I want to be able to roll at, let's say 150 degrees a second. That's pretty reasonable for a fighter. Some do more, some do less. Really up to you. If your fighter is capable of super high roll rates, it'll just do whatever you tell it to, as long as you specify your overshoot correction here. And now this column here tells X-plane where you want the system to start working above. For me, because I know that this aircraft is capable of holding very high angles of attack with thrust vectoring, I'm going to say that it'll just be on all the time, because it is definitely possible that I could get to 0 airspeed in this thing and I'd still want some semblance of stable control. I don't have a system here, so I'm not going to worry about that. And then for roll, I'm going to say above 250 knots, I want this roll rate. So now that brings us to the low speed systems. This is maybe useful if you want your aircraft to have different handling properties when you're at like landing speed and landing configuration. So if you want finer control over your pitch, heading, roll, and all that when you're on approaches, I would recommend setting up one of these. I'm going to say that I can command 5 degrees a second of pitch rate here, maybe 5 of yaw rate, and let's say 45 for roll, just so it's easier to handle on landing. And again, same values here, 0.1 or 0.5. I'm going to go with 0.1 just because I know that's what works with this aircraft. And here you set the speed at which it'll activate below. So for roll, it's commanding 150 degrees a second above 250 knots. So I'm going to say, let's say below 200 knots. Then it'll interpolate between these two. It'll give me progressively less and less roll rates as I get closer to the transition speed. And then because these are all for landing, I'm just going to say, yeah, 200. Actually, I'll keep heading, yeah, 200 knots, and then pitch, I'll say, actually, yeah, just for the purposes of this, I'll say below 200 knots as well. So that's basically all there is to making your artificial stability system. Once you have it made, you may want to tweak the maximum commanded values just depending on how your aircraft handles, or not, really up to you. This isn't an entirely required thing as long as you have positive stability. So, yeah, it's really up to you. I would recommend using a 28-degree angle of attack value in 0.1 and 0.05, but just find whatever works for you. Oh, and I forgot to mention, don't ever check these boxes. They will intentionally destabilize your aircraft, unless of course that's what you want, but assuming that most people following this tutorial will not want to do that. Alright, I believe that's all for artificial stability. If you have any questions, come to office hours, send me an email, or leave a comment below this video. Hope this helps, and see you later.